Hi, this is going to be 4.1.1 statistics for the POE. So what we're going to do is we're going to go over statistics, what it is, and the math that lies behind it. Most of this you've already covered in your math classes, so we're going to go through this quickly. So what is statistics? Well, it's the collection and evaluation of data. Now, statistics comes into two different groups. You can either have descriptive statistics, which describes a collection of data, or inferential statistics, which is generalizing, evaluating populations based on sample data. So, data, we have to first get the data. Now, you can either have it in two different types of data. You can get what is qualitative, deals with the quality or its qualities, data, which is non-numerical data, so color of M&Ms, breeds of dogs, names and labels. Or you can get quantitative data, that's numerical data. That's going to be how much it is, the number of M&Ms, the number of defective parts, the populations, things that you can actually quantify. So quantity, quality. Then, when we do this, we got to take a sample. We are not able to completely get 100% the whole population that you're trying to look at. So you can look at the sampling. So you're taking a small group. Now you can do it at random, or you can do systematically, where you're picking systematically, like I'm going to pick every third person. Stratified, where I pick every 2 people, then skip a few, and then few people, then skip a few. You can cluster it, where you're going to be like, okay, I'm just going to go up to the northeast cluster area to get those people data, or you'll do it based off of convenience, or like it's just easier if I just go next door and do this. Now you can then use graphical data to represent it. Now histograms is a very popular one, looking at how often something occurs. Frequency polygons, which is again it's very similar, but it's going to be a line graph. Bar charts, pie charts. Then we have means. This is your mathematical average. It's take the sum, that's what the E stands for, sigma, sum of all of your pieces divided by how many items there are. It is the mathematical way of looking at the most central tendency. So here is the mathematical mean. You just add up all of these numbers divided by a total number, which is there's 11, and gives you 47.64. Median, this is going to be what is the most middle point. This is going to be where you take the highest to lowest, you range them all in order, and then you just start cutting off. Highest to lowest, take it out. Next lowest and next highest. And you keep doing this. This helps with skewness data and outliers, and it takes out those outliers. So I want you guys to do this. Do the median for this. So now that you've arranged them in order, we take out the 2, cancels out the 63, 63, the 5, 48, and you keep going down to the middle, and you get to 58, the median. Now, if you have an even number, you split it down the middle. So you say 58.5. Mode is the most frequently occurring response, how often something occurs most often. This is the highest point in the curve. It may not be typical or even exist at all. You can have modal, which is 1, bimodal, meaning there's 2 common, or multimodal, 3 or more occurring things. So if we look here, who is the most common item there? Well, we can see 63 occurs twice, and so that is modal. So I want you to determine the mode of this. Alright, notice it's 63 and 59, so it's bimodal. And then you can look at this one. This is trimodal or multimodal. There are 3 commons. So now range. Range is how from the lowest to the highest data. Standard deviation is the square root of its variance. So range, you take the highest minus its lowest. So you look at the highest, which is 63. Its lowest is 2, so its range is 61. Now, standard deviation is probably the most common one that you're going to see outside of the mean average, and the standard deviation gives us our plus or minus factor in our measurements. So we say the average is this plus or minus. That's where the standard deviation comes into effect. So what you have to do is you have to sum up all of the variables minus the average, the mathematical average, square it, all divided by the number of items minus 1, divide it, and then take the square root of it. It's a complicated process, so we'll just work through it. So for instance, we're going to start with just getting the mathematical average. So we just get the mathematical average, 47.64. And then we have to go through and take all of these values and do this for each and every single one. 2 minus the average, square it. 5 minus this here. And we do that for every single value in the whole list. Okay? Then we have to add them all up. Then we are going to take then the bottom numbers, which is how many total numbers. We have 11 minus 1, that's 10. And so we take that number, divide by 10, 502. Then you take the square root of that number, and that gives you 22.4. So what that means is the average, if we look back here, the average was 47.64 plus or minus 22. So then we have graphing frequency distribution. A coin is tossed 3 times, assign the variable to its representation. So we look at our very different possibilities, and we can assign when heads hits up. So we can look at graphing the frequency variations. So we got 3, 2 sets of 2, 3 sets of 1, and 0. And so we can look at the probabilities here, 1/8, 3/8, 3/8, and 1/8. So we can then graph the histogram. This gives us our what we call a histogram, or a frequency distribution. So histograms tell us how often something has. For instance, open seats. You have 5 open seats on a plane 12% of the time is the most common, followed by 4 at 0.09, at 0.07. So we have this whole distribution. Very rarely 12 seats. So that is going to be statistics. If you have any questions, talk to your teacher.